up to the burner here. This is a Venturi style burner, also known as a sidearm burner, but I've turned it into what I call a hybrid burner. This gives me the best of both worlds. I could force air into there, or I could take this fitting off and turn it into just a naturally aspirated Venturi burner. Right now it's a forced draft burner, and I'll show you the forced draft system, how it works. So what I have here is a metal tube coming out, and this metal tube this thing is going to stay generally cool while the forge is running. You can see inside we have temperatures of 2300 degrees. Out here, you know, you can see I can still grab with my hand. It's probably 90 degrees or so. This will dissipate the heat a little bit, and this will allow me to put a plastic fitting into here and make it real easy to attach and detach my hose with this barbed plastic fitting. I just pull it on, put it back on. So as we follow this on down, I'm going to zoom in just a bit. As we follow this on down, you'll see my forced draft system. It is a brand new. This hairdryer runs about $12 to $15. You can find them used on Facebook Marketplace for $5, and you got yourself a $5 blower. Another, what I've done here is I've just it's just a rubber coupling here with another barb fitting that allows me to easily attach my my hose. And in line, I've wired in a PWM controller, which gives me precise control of the airflow just by turning this knob here. So I don't know if, well, I'll zoom back out. Now you can watch as I turn the knob. You see, very reducing environment. I turn it back clockwise, and now we have a very oxidizing environment in there. So like I said, precise control of the airflow. That's the best way I've found to do it. Up on top here, we just have a ball valve to control the gas. What I recommend, though, you'll see this on another forge here, is one of these needle valves. They're just a lot more precise when you're moving the knob there. I've also put in a pressure gauge so I know what my gas pressure is going in. And you know, if you don't have a gun like this to check the temperature, you can also use a device like this. Anyhow, this just hooks to a thermocouple. There's your thermocouple. You can stick a hole in the side of your forge, stick your thermocouple in, and get a nice digital readout of the temperature. These run about $30 or so, and the thermocouple is maybe another $10. So for less than $50, you can get a digital readout, or you can just use something like this. And this is going to measure the surface temperature, where something like the thermocouple over here, you can get a good reading of what the actual chamber temperature is if you were to put a piece of steel in there. So let me know if you have any questions. That's the setup that I think works the best. I'll give you an idea of how well insulated this forge is. So shoot the body here, and the body is right out on the side here, about 288 degrees. I don't know, it's not really focusing in very well, but you you know, for being 2,300 degrees inside and only 288 degrees outside, that's not a lot of heat loss. That's a very well insulated forge. Anyhow, thanks for watching.